Your guys are all correct. It didn't look like a slope of root 3 either, that's why I was pausing. This is 3 root 3 over 2 over a minus 4, and a is 1, so over negative 3. So you're all right. This should be negative root 3 over 2. Yeah, that looks a lot better. So if the slope of this line is negative root 3 over 2, then the slope of this line must be root 3 over 2. And whew, that was a hard problem. So the equations of these lines are the ones which go through 4, 0 with slope plus or minus root 3 over 2. So y equals plus or minus root 3 over 2 x minus 4. Man, if you can do that, you're just like ready to go. All right. Cool? Alice? You good? Every time you got this problem, like 1.5 persons. 1.5. Okay. What was the hard part? You know where to start?
Yeah, like figuring out to use A and B. So like,
Did you do stuff? Did you do like ugly radicals and stuff?
No, I tried. What I originally tried to do was go A, comma, and then B was I moved
Square root of 3
and
halves root
that
blah blah
was
blah.
really terrible.
Yeah.
Just starting the problem was like if you're already off to best. If you didn't know that.
Yeah, it just turns out, I kind of just had a sense, because I've just done so many problems before, I had a sense that it would be better in this case to leave it with 2 variables versus trying to do it all in 1 variable. And I turned out to be right. Plus, Alice backed me up. All right, good. Let's quickly go over some 179 problems. I thought this homework this is really just a practice. This is just really some mindless practice of learning the inverse trig formulas, which I didn't put on the last test, but I will. Yeah, thanks. Or does anyone need another minute to look at that? Wait like a minute. And then so should we do a couple of these? Young Chan, you have a question? No. Let's do should we just do one of these? 17. 17? Good choice. Oh, I guess. So 17 gave you the equation x arctan x equals e to the y, and it wanted the slope at 1 comma ln pi over 4. Okay. I guess I just do it, right? This is actually a combination kind of practice, inverse trig, and also implicit differentiation. So, it's looking a little ugly.
What do I do? Oh,
I had an idea, but I think I'll just do the normal way. So, okay, doing this the normal way, the derivative of the left-hand side, I have to use the product rule, so this derivative of the first times the second. So, I get arctan x. The first times second plus the first times the derivative of the second. So this is the point where you're supposed to just know the derivative of arctan, which is 1 over 1 plus x squared. And what's the derivative of e to the y? The derivative of e to the something is e to the something back inside for the derivative of the something. So you're practicing to be like a vice president of a company that just repeats exactly what the boss said back to him over again. You're like a yes man. All right. Okay. Good. So now I just need to solve for dy dx. Dy dx in general will be just like that stuff. So arctan, this is not a really interesting problem. Arctan x plus x over 1 plus x squared all over e to the y. Well, what they want specifically is dy dx at the point 1 comma ln pi over 4. Jump, jump. So I just plug in, what is arctan of 1?
Root 2 over 2. No, pi over 4. Wait.
It's kind of funny because it was also a homework problem, so it should, whatever. Plus, if you plug in 1 for x, you just get 1 half.
1 half, Mr. Rose.
Yeah, over e to the y, and y is ln pi over 4. So e to the ln of pi over 4 is just pi over 4. Ta-da!
Oh, you just, oh, okay.
You can be
You
simplified.
can make it prettier.
If you multiply by 4/4, then it's like pi plus 2 over pi, or 1 plus 2 over pi.
That's what I said.
Cool. Okay, can I, oh no, you guys probably did this homework like all together, right?
What do you
So
mean
should we
all
just
together?
keep proceeding? So that was the homework that was quote unquote due on Thursday, although I like pretty much said like don't bother doing it, so I'm sure you didn't.
Oh wait, do I have to staple these together or do it?
I think so, yeah, because I think most people probably did it all together, so I'm not gonna try to collect it separately.
Yeah, exactly.
No, but like
I've used
some
like
people,
3. I've used like 3.
some people have just continued to flow, is what I'm trying to say. So wait, no, what I'm saying is don't staple yet, because there was more homework.
There's more homework.
Right? Because the rest of the homework was, oh, did you guys watch the volume video? What'd you think?
I don't
Interesting?
The sphere.
I feel
Spirit thing was cool?
Yeah.
So can I just get a quick poll? Like, what did you do in your geometry class? You didn't do that proof?
It was like, this is the formula. Use this.
Even, but you went to Tacoma or no?
Yeah, what's this Tacoma?
Even in Tacoma they didn't do it?
Yeah, we did like proofs with like triangles.
Anyone do it? Yeah, did you guys do it last year?
We did it.
The way we did that?
Yeah, we did.
We did a couple.
It's like not that hard. It's like kind of hard, but it's not like super crazy hard.
Pour water into it?
What?
Pour it into a color?
Yeah, people just pour water.
Hemisphere plus a code. It's like the volume of the cylinder, and you can get the volume of the sphere by finding the volume of the hemisphere.
I mean, pouring water is nice and all, but like, anyway, now you got the real proof, so you're welcome. There was also a surface area video, which I called optional. Did anyone watch that just like for fun? It was kind of cool.
For fun.
That's right.
Oh my god. I saw optional and then just like skipped over it.
You know what else is optional in life? Being awesome. So, you want to take that option or no? I think you should. Alright, so there's a surface area video, most of which was like a little bit boring, but the last like 7 minutes of the surface area video is kind of cool because I do the formula for the surface area of a sphere, which I think is the highlight of the whole series.
Wait,
Alright.
so you spent the time to like print out all
was
the little
surface
colored
area?
things.
Yeah,
That was like
Yeah.
like scared me the most. I was like, wow, like
Yeah,
like,
I
you know
got
how
my
long
student aide
this-
to cut them all out and put them
that's what
It took her like over an hour. Alright. Free labor. That's the best kind. Okay, good. The point is that we learned related rates on one of these days, like Thursday, correct? Thursday we learned related rates? Yes.
No.
Okay, so
Oh,
I'm
yeah.
sorry, Tuesday we learned, must have been Tuesday that we learned related rates. Is that correct? That must be correct. You guys just say yes to whatever I say. Alright, Stephen, we learned related rates on Tuesday. And so what I asked you to do is to finish the packet and also to do just 4 problems. Because I've learned that related rates are pretty hard, and so I'm gonna really baby you guys at first. Just 4, then we're gonna go over them, then like 4 more, and we're gonna go over them like 4 more, okay? So, except we really only have like a week to do all that.
It's going so fast. How are we always out of time?
I don't know.
Yeah, I know.
Yeah.
We're going really.
Because of pauses for whining by certain students.
Okay, that
So.
shade was not very like.
Okay, good. So let's go over amongst the 2 related rates problems that you have to finish on your own from the packet and the 4 for homework. I feel like we have time to do maybe like 2. Which 2 from of those 6? Which would you like?
19.
I think we should do number 5 from the packet, and we should do 1 of the ones from the book.
33.
There was one from the book that was like almost exaggerated.
So you're saying we should not do that one? The baseball one we should do or not? Not? Okay, so number 5, we go. Number 5 from the related race packet, I'm starting. Number 5 says, a man walks along a straight path at a speed of 4 feet per second. Okay, the man's walking on a path. I got it. It's quite fast. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? and how fast is he moving away from the searchlight at this same moment. All right, these are really 2 questions. All right, I have read and understood the problem. Next, I will make a picture. Here is my picture. Here's a path. Here is a man walking along the path. And let's say he's walking in this direction, and he's walking at 4 feet per second. All right, there is a searchlight which is located on the ground. So this is like aerial view. It's located on the ground 20 feet from the path. So here, perhaps I shouldn't have put the man there. So the searchlight is here, so I can draw, so I'll just, it's a sun. So here, no, that's actually really bad. The searchlight looks kind of like that. Okay, and the searchlight in a 2-dimensional sense can rotate, and it will rotate such that it stays focused on the man. So the searchlight is located on the ground, and it's located 20 feet from the path. So the searchlight is not moving. There's a lot of reading comprehension involved here. The searchlight is not moving, and it is 20 feet away from the path, and distance means like, perpendicular distance. And it is kept focused on the man. All right, so actually, if you think about this, there are 2 things which are happening here. The camera, suppose you do not have an autofocus camera. These are these kinds of questions. Okay, so what are the 2 questions? We want to know at what rate is the searchlight rotating, and also how fast is he moving away? Okay, so we need to do 2 things. If suppose this were like some kind of like robot thing where you're going to have you are programming the searchlight to stay focused on the man, and you knew exactly how fast the robot was walking. Okay, you would do calculus to figure out, well, if the man is walking at this certain rate, at precisely what rate must I continue to rotate the camera so that the spotlight stays focused on the man? This is actually a very reasonable question. And in addition to how much I have to rotate the spotlight to stay focused on the man, I also, supposing it's not autofocus, need to control the focus in such a way that I change the lens or whatever so that the man stays in focus, because we're spying on him for like a bad TV show or whatever. See if he's cheating on his, I don't know. All right. So to keep him in focus, we need to know how far away he is, right? So at every single moment, we need to monitor 2 things. We need to monitor where he is, so he stays in frame, but also how far away he is, so that we can adjust the camera lens. Are you guys kind of with me? I think you are. All right. So I have read and understood the problem. I have drawn a picture. It is now time to pick variables for the quantities which are changing. What quantities are changing in this problem? Yes?
The angle.
The angle is changing. I will call this angle theta, and because we are in calculus world, that is in radians. So let theta be, I'm a little bit too lazy, I'm just lazy, so I don't feel like it, and I'm also experienced, so I kind of don't have to, but you should either write down on your paper or write down in your brain, let theta equal the angle between the line connecting the man and the camera and the perpendicular distance to the path in radians. Okay, what else is changing?
The distance.
Calvin again.
The distance the man has walked.
The distance, which do you mean? Be more specific.
Well, both of these are changing, so I mean.
Okay, let's call this x. Let x be, again, write it down on your paper or in your brain. Let x be the horizontal, or the distance the man is along the path from the point on the path closest to the searchlight. And, I think there's another quantity which is changing.
The hypotenuse would.
Yeah, the distance the man is from the searchlight. Alright, this is a hard problem mostly because of the thinking and the reading and comprehension and the mathematical modeling associated with the problem. Okay, good. Read and understand the problem. Draw a picture. Pick variables of the quantities which are changing. Add those variables to your picture. Restate the information given in the problem in terms of those variables. What do they tell us? What do we know? Yeah?
dx dt is 4.
Exactly. I know how fast the guy is walking, so I know that dx dt is 4 feet per second. Okay, and what is it that I want? I want to know two things actually, right? The first thing I want to know is at what rate is the searchlight rotating when the man is 15 feet from the point in the path closest to the searchlight? In other words, what I want is, just like he said, I want d theta dt, not in general, but at x equals 15. Okay, it's just so clear when you write everything out like this. And then in part 2 of the question, I want something else. What else do I want? How fast is he moving away from the searchlight at the same moment? So what I also want is ds dt at x equals 15. All right, I mean, in my opinion, this is hard. I think this is hard. And once you have gotten, however, the good thing is, once you have gotten this far, you have done the hard thinking part, and now you can slightly kind of just zone out for a minute and do some math. So let's do that. Oh wait, maybe not quite yet. So read and understand the problem, draw a picture, pick variables, add the variables to a picture, restate the information, and then finally find a relationship between the variables. What is the obvious relationship between these variables? Let's suppose we're going to answer this first question first. If I'm interested in d theta dt, then I need a relationship that gets theta involved. What should I do? Tan.
1
Yeah.
over 1.
I'm seeking a relationship simply between theta and x for starters. Because I want to know, okay, so because x is the rate at which I know and theta is the one I want. So what is the relationship between x and theta? Solving this first question first, we usually x theta is that tan theta is x over 20, or x equals 20 tan theta. Okay, awesome. This represents the static relationship between x and theta. Now, differentiate both sides with respect to t. There's no reason to solve for theta either, by the way. No, if you suddenly got arctans involved, that was totally unnecessary. Watch this. Ron, you're going to see that was totally unnecessary. Because once you know there's no reason to solve for theta, I can just differentiate both sides with respect to t. So if I differentiate both sides with respect to t, I get, on the one hand, dx dt, and on the other hand, the derivative of 20 tan theta with respect to t is 20. Derivative of tan theta is secant squared theta back inside d theta dt. Cool? Cool. Okay. So what do I want? I want d theta dt. So if I want d theta dt, then that's just dx dt divided by secant squared, which really means times cosine squared theta over 20. All right. And now, everybody with me? Now I can plug in dx dt because I know what that is. It's 4. So this is really like cosine squared theta over 5. Okay. So finally, that I've solved for d theta dt in general, now it's time to answer the question. The question is, what is d theta dt when x is 15? So what is d theta dt at x equals 15? Well, we have to be a little bit smart now because I can't just mindlessly plug in x equals 15 in here because this formula is in terms of theta. So now comes that optional sort of step where I have to draw another picture, a static picture now, of what this situation looks like when x is 15. And okay, do you guys kind of see, you can do this fast in your head because this is basically just like a 3, 4, 5 triangle but scaled up by 5. By 5. So this is 25. And thus, what is cosine theta? Cosine theta is 4/5. Right? So much going on here. There's a lot of math. So if cosine theta is 4/5, then cosine squared theta is 4/5 squared. So I get 4/5 squared. That's what cosine squared theta is when x is 15 all over 5. Final answer, 16/125. And what are the units? Arun, are people's heads in the way?
He moved. We're good.
Yes or no?
No, not anymore.
Okay. What are the units again? Radians per second. Yes.
How do you know it's radius?
La 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 la. You know it's radians because
You have to use radians to do, like, these don't work.
all of our trig formulas all assume radians. Back to the very most basic limit of all. This limit, the limit as theta goes to 0 of sine theta over theta, this is 1. This only works if theta is in radians.
I don't think anything we did requires it. Does it?
Definitely. Because this limit is only true in radians. In degrees, this limit is not true. If you think about it, right? If you're in degrees, the sine function looks, I can't even draw it without, like, I need like 100 feet of whiteboard. Because if I draw it like that's 1, can you see?
So all the derivatives are also.
That's 1. Then 360 is like over here, but like that's not even to scale, right? So it's like really stretched out. In degrees, close your eyes if this is going to freak you out. In degrees, this is not true. In degrees, the limit as theta goes to 0 of sine theta over theta is going to be like something really terrible. It's going to be like pi over 180. Pi over 180. It's going to be really stretched out. Is this making sense? I usually talk about this earlier in the year, but I didn't this year. So it was actually at the moment when we proved this fact that we were committed to using radians forevermore. Stein used to teach analysis 1A. He called this like the tragedy of whatever day it happened to be when we would prove this fact, like, you know, February 3rd or something. It was called the tragedy of February 3rd. The tragedy is, it's not really a tragedy, is that you just have to use radians from now on because everything that follows, and that limit was used to prove the root of sine, which was kind of a cascading effect. So you just know you're in radians. All right. So much, man. Too much. No, just kidding. Just enough. Number 2 said, what is ds dt when x is 15? Again, the rate that I know about is x, and the rate that I'm interested in is s. So I seek a relationship between x and s. So this is really like a whole separate problem. What is the relationship between x and s?
Pythagorean theorem.
The Pythagorean relationship. X squared plus 400 equals s squared. And again, make maximum use of implicit differentiation. So this is 2x dx dt equals 2s ds dt. And now I solve for ds dt. Oh, did I tell you guys to check this online?
Yeah.
Oh, so is that why you're all looking so bored? Because you already like didn't. I mean, did you figure this out on your own, or did you try and then check online? What?
Why did you just think about sleep?
Because she was just looking so bored. She was just looking like something. Sure, I get this. So please move on to something else. I'm so bored.
No, I like it when I hear you say.
Yeah, sometimes it's fun to listen to someone do something. It's like watching a movie twice.
It makes like sense. Watching movies
Boring movie about that. Alright, so ds dt, am I even doing this right? I'm just writing like random nonsense. Okay, what is ds dt? ds dt is x dx dt over s. I just bought this book. This is a total non sequitur. I just bought this book, but it came in the mail literally like an hour ago. I have all my things shipped to Blair because they won't deliver it to my house.
Why?
See?
Why? They will.
It's really no, they won't. They like UPS doesn't have a key into my building, so they won't leave packages because like people just steal it. It's called White Light. It's about a math professor who just hates students. And, I love you guys. He thinks about infinity all day long, and he's like a weirdo, crazy guy. He sleeps on the floor in his office, and he stays up all night, and then he just like And then he just like dreams and like enters weird like worlds of like infinity. No, it's like fiction. It's like sci-fi cyberpunk.
No, wait,
Here,
isn't that how you
read it.
spend your
I'm really excited to read it. I heard some really good things.
Can
on
we
the
have
internet.
story time
Just
for like
came in
5
today.
minutes every class?
We
Yeah.
might
take logic if you want story time.
Yeah, you should take logic when you're students. All right, good. Finishing off this problem because we need a break is the xt is 4, so this is actually just like 4x over s. And so finally, ds dt at what is it? At x equals 15 is going to be, well, it's going to be 4 times 15 over whatever s is when x is 15, and the answer is 25. So, and that turns out to be 3/5, so this is going to be 12 fifths, and the units feet per second. Okay, how are we feeling about this? Okay, let's do one more related rates problem, and then
33.
let's take a vote. Who wants to do 33? 1, 2, 3, 4, 5, 6, 7. Who wants to do a different problem?
Yeah, oh my God.
What's the different problem that you want to do?
Number 19.
Who wants to do 19? Sorry, Calvin, 33. Okay, 33 is about baseball. The most boring sport. What?
Thank you.
Yes! You hear that, Scott?
Yes, Scott.
Oh, I'm sorry, Scott. Everyone else loves baseball. It's really hard to work in this department. Ostrander's obsessed with baseball, Stein's obsessed with baseball, Giles likes baseball, Lodall's obsessed with it. It's like all they do is talk about baseball all the time.
Rose, you should write
It
puzzles.
is.
Puzzle.
Alright.
I literally.
Number 33, a baseball diamond
It's hot.
has the shape, what's up? Good. Yeah, tell her to stop talking. Alice, control your partner. A baseball diamond has the shape of a square with sides 90 feet long. That is a fact. I will draw a baseball diamond.
You know, I think so. You talk to.
Okay, this is 90, etc., etc. Okay, a player running from second base to third base at a speed of 28 feet per second is 30 feet from third base. Okay, so here is our guy. He's running this way, because that's second base and that's third base. He is 30 feet away, but that's actually not, I'm not going to add that to my picture, because that's like the particular condition I'm going to do at the end. What does matter is that his speed is 28 feet per second. Okay. And the question is, at what rate is the player's distance from home plate changing? Okay, so here's home plate, and here is our guy. And what I'm interested in is how far the guy is from home plate. Scott, is this like a reasonable, why would you want to know this? Suppose you were programming robots to play baseball for you.
What?
Okay? So it's the 2030, that's what's going on. It's the 2034 robots versus humans challenge. They've already tackled like chess, Jeopardy, tic-tac-toe, like there's like almost nothing we can do anymore. They can tell whether we're lying like better than we can. They're even like better at emotions than we are now. So
Oh yeah.
Yeah, working was like a while ago.
Yeah.
go straight to baseball. So we're playing against where it's a bunch of robots, and this human is running at third base, and we know he's running at 28 feet per second. Okay, and so the question is, I guess maybe like there's like a robot shortstop here, right? There's like a robot shortstop, and you play softball also, don't you?
I have a scrimmage today.
Oh, exciting. So there's a robot shortstop, and the robot shortstop is keeping up with the guy, and like maybe like a catcher has the ball at home plate, and so he wants to throw it, and so he's calculating. The robot is doing calculus, solving related rates problems, calculating how fast the throw is going to make it to the shortstop. It's semi-reasonable-ish, maybe. That we would want to know. We would, right? You kind of, but that's something you do in baseball, right? At every moment, you're calculating like kind of how far away you are.
No, you don't
You're not calculating. You use intuition. Yeah, you just do it. No, but like you need to know whether to throw it to one person or the other. Yeah. Back me up, Scott. Back me up.
Well, I would just throw it to
Baseball, let me get my TI.
Exactly. Third baseman had a system malfunction.
And then you
So just calculate the distance between them.
All right. Good. We're all learning things here. Also screwing around, I'd say. All right, we're back. So what I've read and understood the problem. I have drawn a picture. I need to pick variables for the quantities which are changing. What quantities are changing? The distance he is from home plate is changing. And?
That's right.
Yes, using a reasonable modeling procedure, Alice says, let's let x be, that's not the only way to do it, but it turns out to be the simplest way. Let's let x be the distance the guy is from third base. Cool? And then since this is a diamond, 90 on sides, also known as a square, this is 90, and now I think then the problem becomes kind of suddenly pretty easy. Because what we want is, what's given is, actually this is a little bit interesting, what's given is what? What's given? dx dt is,
Negative 20.
you probably could get away with saying 28, but it is more correct to say negative 28 feet per second, right? Yeah. Because, no, it is negative because x is getting smaller. As he runs, x is getting smaller, right? So the rate of change of that variable x is a negative rate of change. Okay, good thing they didn't use meters. I would get angry. This is America. This is baseball. All right. And what do they want? They want to know the rate of change of s. So what they want is ds dt at what? No, careful. Ken, don't have yet. You have to continue thinking for at least a little bit longer. At x equals
6:30.
30.
not 30. Something.
Asking for
Oh, you're right. I'm
30.
sorry. 30 feet from third base. I read this wrong. Yes, it is x equals 30. Yeah, they want to know what dx dt is when x equals 30. Okay, now I seek a relationship between the variables. I think the relationship is pretty obvious, right? It's x squared plus 90 squared equals s squared. So what was hard about this problem? The reading comprehension part?
The answer not showing up right.
Oh, so you got this far? Oh, interesting. Okay, so now let's differentiate both sides with respect to t. I get 2x dx dt equals 2s ds dt, divide both sides by 2. So ds dt is just x dx dt over s. And I know that dx dt is negative 28, so that's negative 28x over s. Okay, looking good. But I specifically want to know what ds dt is when x is 30. So when x is 30, I get negative 28, well times 30 over, and now I have to do a side calculation to figure out what is s when x is 30. Okay, so I have to basically do a little Pythagorean theorem. Okay,
But
terrible
you have it
design.
right there.
Do I?
Yeah, right there, like the x squared plus 90 squared.
Yeah, but I don't want to like mess up that picture. Well, I don't want to change that picture because I want to leave x in general. Because now I'm drawing a particular static, totally static picture. When this is 90 and this is 30, what's this? Okay. And do you guys know like the cool way to like do the Pythagorean theorem fast in your head?